So let's do a warm-up exercise. Street lights in San Francisco. The question is, how many street lights are in San Francisco? And since it's a warm-up, I'm starting by saying San Francisco is a city which covers an area of 7 by 7 miles. So I'll wait here for a minute and let you think about how would you do step 2, the decomposition of this problem into component variables. And then I'll show you my approach. So everybody got their approach? So here's my approach. First variable, I gave you that variable. The city's total area is 49 square miles. And now the next variable is, well, what we're trying to get to is how many city blocks are there in San Francisco? That is the first big component variable. And then the second big component variable is, well, how many street lights are there in any given block? So my estimation was that a block, which is rectangular, not square, in San Francisco, there are 10 blocks to a mile. And my assumption is that the width of the block is half the length. So I'm dividing the 49 square miles by 0.1 times 0.05 square miles per block. And then my assumption is there are 3 street lights per block. Now that sounds like a low number, but the essential realization is that in a city, there are typically street lights only on one side of the road. So you have 4 sides of a block, but only typically on average, 2 of those carry street lights. The other sides are illuminated by the street lights that are in the block on the other side of the road. So, and then we have one long length of the block. I put 2 street lights there and 1 short, and I put 1 there. So I multiply this with 3. And if you do this, you end up with 29,400 streetlights in San Francisco. The actual number is 46,000. So we come out at within kind of 2x. For the fun of it, New York has about 10 times the area of San Francisco. New York has roughly 300,000 streetlights. So this was a very simple one. I told you 5 to 10. This only has really 2 component variables just to demonstrate the principle.